Okay, this is 7.2 homework help. The first problem gives us two matrices here, and matrices are just a collection of numbers like this put in a rectangular array. So nothing special about these, but we can use these to represent, like, the coordinates of objects, or things like that. So the first one wants us to multiply these matrices. It says, is it possible, first of all? Well, the first one's a 2 by 3. You go row by column when you do size. And so this one's a 3 by 3. And if you're multiplying b times f, if the middle number is the same, then you can do the multiplication. And what you're going to get is a 2 by 3. So that's really important. So yes, we can do the multiplication because the middle number is the same. We're going to get a 2 by 3, and we can do this in our calculator. We're just going to enter in, go to second matrix, and then scroll over to edit again, and go ahead and call this is matrix A instead of matrix B, but oh well. It's a 2 by 3, and enter in the numbers. All right, and then go back. Once you have that done, go back to second matrix and do edit, and then we'll call FB. Matrix B is also, and then go ahead and do a 3 by 3 and enter in those values. And once you have those entered in, you can just quit out of there and just go to second matrix. The first one B, I called A, times, and then F is matrix B, so second matrix, and scroll down and hit enter on B. And hit enter, it gives us our answer right here. Now it's asking for the numbers like, A sub 1, 1 is the first one, negative 15, and you get the idea. So just try to match this up, with each of these numbers. Okay, the next problem is it wants you to do A times B and then subtract B squared. Let's just do that right in our calculator. So pull up the calculator and send to A and B, and just go ahead and evaluate this part. So second matrix, edit, matrix A is a 2 by 2. Go ahead and enter the values. Once you get that done, go to second matrix, over to edit again, but this time matrix B, which is also a 2 by 2. Enter the values in. Once you get that done, just go and evaluate this expression. So second matrix A times second matrix B. And then we're going to subtract from that second matrix B squared. So enter, and we get this matrix here, 1762, and they want it like this, 1762. This one you can go ahead and do it in the calculator again. I don't think I need to show you this. Just enter this into A and B and do the multiplication. I will show you in class as well how to do this by hand if you're interested. It is good to know how to do it by hand as well, but in interest of time, we're just going to do it with the calculator for now. This is another one of these that you can do in the calculator. Just enter this in for A and B or whatever, and then do the multiplication. Now matrix B is a 2 by 3, and matrix F is a 3 by 3. So once again, if the middle term is the same, you can do the multiplication, which you can in this case, and what you're going to get is a 2 by 3 for your answer. So just go ahead and enter those into the calculator, do the multiplication, and get the answer. Now you could not do F times B, so matrix multiplication is not commutative. Order does matter, because if you did F times B, you'd have a 3 by 3 and then a 2 by 3, and the middle terms would not be the same. So you would not be able to do F times B, but you can do B times F. All right, the next problem gives us 3 matrices here. It says, then decide if each of the following operations is defined, yes or no. So first for addition, when it comes to addition, you have to have the exact same size matrices, which we don't. This is a 4 by 2, this is a 1 by 4, and this is a 1 by 3. So no, for each of these, when you add these matrices together, you can't do it. You need the exact same size, and you just add the corresponding elements. It's really easy to add matrices. All right, so when it comes to multiplication, A times B, once again, we talked about the middle term has to be the same. So when it comes to A times B, 2 and 1 are not the same. Therefore, that's not possible. B times A, the middle term would be 4 in this case, which is possible, so we could say yes for that one. A times C, the middle term would be 2 and 1, so that is not possible. C times A, the middle term would be 3 and 4, so that's not possible. B and C, B times C, the middle term would be 4 and 1, so that is not possible. And C times B, the middle term would be 3 and 1, and that's not possible either. So 6 is a similar type of question. Can B times C be performed? Well, B is 2 times 3, and C is 2 times 3. So if you do it in that order, the middle terms would be 3 and 2. So my answer would be no here. It might help for you to write it, when you're doing the multiplication like this, B times C, and then write the size underneath, because that way that's easier to see the middle terms here. But these have to be the same when you multiply matrices. All right, so when I do C minus B then for this one, since these are both the same size, 2 by 3s, I can do this subtraction, and all you do is subtract the elements. So take every element in C and subtract the corresponding one in A. So 0 minus 1 gives you -1. -1 minus 3 should give you +2. 5 minus 0 is 5. -3 minus 2 is -5. -5 minus 0 is -5. And -1 minus 4 is -5. You can also do that in a calculator if you enter this in for matrix A, for example, or it doesn't matter. And then for B and C, enter these into your calculator and just do the subtraction. It'll give you the same answer. All right, the next problem, you can do this in the calculator as well, but I'll just do it by hand. When you multiply a scalar times a matrix, you just multiply it through. So 3A becomes 0, 6, 15, 3, -3, -6. And I need to add that with 2B. 2B becomes 0, 4, 10, 2, -2, -4. So that when I add these together, just add the corresponding elements. You get 6, 10, 25, 5, -5, and -10. Okay, this next problem here is not what I'm going to ask you on a test. So you don't have to necessarily know how to do this by hand. But if I write out this equation, A times A would be A squared. So on the left side, I'd have x 6, y -3 times itself, which would be x 6, y -3. And that has to equal A, which is x 6, y -3. All right, so A squared equals A. Now, when you do this multiplication by hand, what you do is you take a row and multiply it by a column. So this gets multiplied by this gets multiplied by this, and then they get added together. So what happens is you get x squared plus 6y, and that goes right here in this location once you do that. So it must equal x. There's one equation written from multiplying this out, and you just follow that pattern. So you just go back through now. That equation wasn't that helpful anyway, so let me get rid of it. Now you do this row times this column. You multiply x times 6 and 6 times -3, and you add those up. So that gives me 6x plus -18, and that goes now in the next spot, which is right here. So that has to equal 6. That's an equation that's helpful because that solves for x. So if I add 18 to both sides, I get 6x equals 24, so x equals 4. All right, and now you can just solve that same thing now. If you just keep going, you'll see that y times x would be the next equation. This row times this column now. And then the last would be this row times this column. So you always do a vertical row times a horizontal row times a vertical column. And the order you go is first times first, and then first times second, and then second times first, and then second times second. So that's how you actually multiply matrices. And you put it 1, 2, 3, 4. Now it's easy for a 2 by 2, but it gets a little tricky for bigger ones. But you follow the same pattern. So if I do the last one, if I do last times last, that should equal this number. So that'd be 6y plus 9 equals -3. So if I subtract 9 from both sides, I get 6y equals -12. So y equals -2. There's my answer. Okay, for inverses, we're not going to do these by hand. There is a formula. You can find it online or in our book, the PDF that I can make available to you. But it's pretty easy. You have to learn something called the determinant. But for now, since we are running out of time, we're going to do this by hand. So we go to second matrix and enter this matrix N for matrix A, for example. All right, once you have it entered in, we'll just quit out of there, and we'll go second matrix and grab matrix A, and then we'll hit the inverse button right here and hit enter, and that gives us the inverse. Now I'm going to hit math fraction and see if I can make fractions out of those, and it looks like I can, and so there's my answer right there. Alright, so I think you can handle that. Problem 11 is the same thing. So, you know, for this last one, I would have said yes here, obviously, because the inverse did exist, and it gave me an actual inverse. Same thing for problem 11 and problem 12. I know this is a 3 by 3, but we're going to go ahead and do the same thing in the calculator.